Okay, so we're working on 3.11 Part A, solving linear systems by graphing. So for 3.11, we are working on solving linear systems, and there are actually three different ways to solve a system, but we're just going to take a look at the graphing way for solving a system. Okay, so that's why I've split it into Part A and Part B. So Part A, we're looking at graphing. Okay, so number one, when we are solving a linear system, we are trying to find where the two lines intersect. Intersect, or another word, meet. So for example, if we're looking at two different lines, let's say that's one line, the other line might look like this. So the solution, or what we are trying to find, is this little point right there, and it's going to have a coordinate value. So an x and a y value. So that's what we're looking for. We're looking for where the two lines intersect. All right, so number two, the place where they intersect is called the, and I already said it, it's the solution. Solution to the system. So what we're looking for is a solution to our system, and the solution is where they intersect. Okay. So when we're graphing lines, there are three possible solutions that we can come across. Okay? And each of these solutions have a slightly different way that you present your answer. Okay, so we're going to take a look at the different solutions for graphing. Okay, remember this is the graphing. All right, so first option, let's take a look. Option number one, they intersect at one point. Okay, intersect at one point, and that point would be x, y. For example, as I did up here, they intersected at one point. Okay, since they only intersect at one point, it's very easy to give your answer as an xy coordinate. Okay, so for example, let's try and create one line. So, whoop, there's one line. I'll draw in the other line to see where they intersect. Okay, so I have drawn my system, two lines. What would the solution be, or where they intersect? Right here. And because this is a hand-drawn graph, I'm not going to have a perfect answer, but it looks like they intersect at the coordinate point 1, 1. So my answer for this graph would be the point 1, 1. Let's take a look at another example for our first option of intersecting at one point. Okay, so let's see, maybe we have a vertical line and then a horizontal line. Okay, so here's my system. So go ahead, pause the video, see if you can find the solution for this example. All right, so let's take a look. What would our solution be, remember? Our solution is where they intersect. So the red line intersects the blue line at this point. What is the coordinate point for that point? Well, it's going to be -1, and then up 1, 2, 3. -1, 3 would be the solution for that graph. All right, so for this option where they intersect at one point, you're going to answer as a coordinate pair. A coordinate pair. And that should be as a coordinate pair. So that is how you would show your answer for this possibility. All right, two more to go. So the second option that our two lines can appear is they can possibly never intersect. It's kind of strange. In this one, they intersect once, right? Because they're crossing. But it is possible for two lines to actually never intersect. You remember what kind of lines those are called? They're called parallel lines. Okay? So parallel lines, sometimes they never actually intersect. For example, we have this line here, and then running perfectly alongside it is another line which is parallel to it, maybe down here. These two lines, they are never going to intersect. And I am trying to find where they intersect, because where they intersect is the solution to my problem. Remember, we want to find a solution, but these guys don't ever intersect. So I actually don't have a solution. Okay, so our answer for these types of problems where they never intersect, our answer is going to be, well, there is no answer. They don't intersect. So our answer is no solution. Okay, they never intersect, therefore we don't have a solution. Okay, so another example for you guys to see. Let's say I have one line running this way, and then another line that never intersects with it might be this one. Okay, so once again, they never intersect. So, no solution. An easy way to tell if there's going to be no solution is you look at the slope. Okay, if you look at the slope and they have the same slope, so remember the slope is the way our line moves. So if they're both moving up and across at the same exact pace, but they start at a different point, they're never going to intersect because they're both moving up at the same amount and then moving right at the same amount. Up and then right. Okay? So if we look at the slope, if it's the same slope, but they have a different starting point, then it's going to be that they are parallel lines. They are never going to intersect, so we will never have a solution. All right, so we had option 1, they intersect at one point. Option 2, they never intersect. Option 3, what could it be? Option 3, they are the exact same line. We were tricked. We were looking at the same line. They are the same line. That's kind of interesting. All right, so let's take a look at how, or like what do I mean by the same line? So let's say we have this line here. We graphed that line, and then we go ahead and we graph the other line in our system, and it comes out that they are the exact same line. They fall right on top of each other. Well, what would our answer be for this kind of option? Remember, we are looking at where they intersect, because that's our solution. So where do these two lines intersect? Well, they intersect here. They also intersect here, and 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 so on. In fact, they intersect infinitely many times. I can find a point here, 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 here. They are the same line, so each point is intersecting the other line. And how many numbers are on the number line? Infinitely many. You cannot count them. So our answer for when they are the same line is infinitely many solutions. It's kind of a long answer. Infinitely, I hope I spelled that right. Infinitely many solutions. Okay, so if you find out they're the same line, please write your answer as infinitely many solutions. If you just wrote many solutions, I don't like that. Please write infinitely many solutions. So try pause the video, see if you can come up with another example for the same kind of line. Okay, so let's take a look at another example. Maybe our first line looks like this, and our second line looks like that. Once again, they're the same line, so the answer is infinitely many solutions. Okay, a quick summary. We have 3 options for graphing. First option, they intersect at one point. Your answer will be a coordinate pair. Second option, they never intersect. So your answer will be no solution. Third option, they are the exact same line. So your answer will be infinitely many solutions. Okay, so let's take a look at an example problem. Solve the system by graphing. Okay, so notice I tell you how I want you to solve the system. So if on the exam, for example, it says solve by graphing and you choose to do another method, you cannot get the points for this problem. If I give you a method, please go ahead and use the method I have given you. So since it says solve the system by graphing, that's what we're going to do. All right, so notice my two equations are given next to this little squiggly bracket. That kind of indicates to my reader that we're looking at a system. Okay, so what would the plan be for this? Oh, look, there's a plan sticky note for solving linear systems by graphing. How neat. Let's take a look at the plan. All right, so the plan. Number 1, graph the first line entirely. And remember, this is how we graph lines. We look for the X-intercept, the Y-intercept, and the slope. All right, let's go ahead and do that. So, first line. It really doesn't matter which line you pick. I'm just going to pick the one at the top, as that's the first line. So our first line, x minus 2y equals 1. Ooh, that was an ugly line. Okay, go ahead and pause the video and see if you can find the x-intercept, the y-intercept, and the slope. All right, let's go ahead and find the x-intercept. Okay, so how do we find the x-intercept? Remember, we set y to 0 and solve for x. So x minus 2y equals 1. We're going to set y to 0, or substitute that in. So 2 times, we have turned y into 0, equals 1. Solving this, x minus 2 times 0, that goes to 0. So we're left with x equals 1. So our x-intercept is 1, 0. Please write your answer for your x-intercepts as a coordinate point. If it's not a coordinate point, you may lose a few points on your exam. So please remember, write it as a coordinate point. Let's go ahead and plot that. 1, 0, right there. So this is going to be, my first line will be my red line. All right, so we found the x-intercept. Next thing to do is find the y-intercept. Okay, go ahead, pause the video, see if you can find the y-intercept. All right. So the y-intercept, how do we find that? Well, we set x to 0. So, exact opposite. Using the same equation we're working with, we're going to set x to 0. So x becomes 0 minus 2y equals 1. That becomes minus 2y equals 1. Solving for x, we will divide both sides by negative 2. So y equals negative 1 over 2. And once again, we make that our coordinate point. Box your answer. And let's go ahead and plot that point. So 0, negative half. That's about there. All right, so remember, when we're graphing a line, we need 3 points. So to find our third point, we're going to use our slope. So let's find the slope. Okay, to find the slope, we need to get our answer in y equals mx plus b form, or slope-intercept. And at the moment, our equation is not in that form. So we need to solve for y. Get y by itself, we're going to subtract x from both sides. Sorry, I'm not certain if you can hear the geese honking in the background, but I do live in Waimanalo, and there are lots of animals around. And I made the mistake of trying to record this video during the day. I apologize. All right, so minus 2y equals negative x plus 1. Almost have y by itself. To get y by itself, let's divide by negative 2. And we are left with y equals, negative divided by negative. That's positive. So 1 over 2x minus a half. Alrighty, and from this, remember, the slope is the number by x, which is going to be this little guy right here. So our slope, m equals 1/2. And how is that useful to us? Well, with our slope, we can start at any point. So we could start at this point or this point, and we will count up our rise. So rise 1, and then our run, right, 2. So I will start with this point, my x-intercept, because this one's kind of weirdly not really on a tick mark. So I'll start with this one. We're going to go up 1, and then, let me use a different color. We're going to go up 1, and then what did I say? Right 2. And there we go. And sorry, my graph is hand-drawn, so they are not lining up that nicely. Okay, so let's go ahead and draw our line in. I'm using this because I can't find my ruler at the moment. And there we go. So our first line is drawn. Okay, so go ahead and I'll set you up for the second line. I'm going to call this one blue. So second line. Our second line is the equation y equals, what was it? Y equals negative 1/3 x minus 3. All right, so go ahead, find the x-intercept, y-intercept, and slope. Okay, so I'm assuming you've paused the video and tried that by yourself. So for the x-intercept, remember we set y to 0 and solve for x. So using our equation, setting y to 0, we have 0 equals negative 1/3x minus 3. Solving for x, let's add 3 to both sides. Then we have 3 equals negative 1/3x. All right, so because I have a fraction near that x, I'm going to multiply both sides by the reciprocal of 1/3. The reciprocal of 1/3 is 3/1. And I will also multiply by a negative to cancel out that other negative right there. So multiplying both sides, what do I get? Well, these 3's cancel. The negative times the negative becomes a positive, so I'm left with positive x on this side. Then I have a negative 3 times a 3, which is going to be negative 9. So my x-intercept is negative 9x. Let's go ahead and plot that. We're plotting in blue. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, just enough room. All right, and that was my x-intercept. Remember, we need to have them answered as a coordinate point. Let's find our y-intercept. So for y-intercepts, we set x to 0. Very good. Using the same equation. Setting x to 0, what do we get? So y equals negative 1/3 times x minus 3. That goes to 0. So we have y equals negative 3. So our y-intercept is 0, negative 3. Let's go ahead and plot that point. 0, negative 3, 1, 2, 3. Ooh, we're almost there. We have almost graphed our second line. The last thing we need to do, let's take a look at our plan. Last thing is the slope. Okay, so how do we find slope? Well, we need our line to be in the y equals mx plus b form to find slope. Hey, and what do you know? Our line is actually already in that form. How neat. So, easy thing. Just look at where x is. X is right there. Take the number in front of x, which is the negative 1/3. So m equals negative 1/3. Sorry. Remember, we can start at either of these points. I could start at this point or this point. The slope just tells us how to get from one point to the other on our line. So what does this slope tell us? Okay, this is kind of strange because it has the negative, so you have to choose. Will I put the negative with the 1 or the negative with the 3? And for this line, I'll show you how to find the other point starting from this one or this one. So I'll show you two different ways, and you can choose which way you prefer. So for our slope, let's say I chose to put the negative with the 1, which means I'm going to go down 1, and since the 3 is positive, right 3. So for fun, I'll start at this point. We're going to go down 1 and right 3. 1, 2, 3. So that's my other point right there. And then let's try and see if we can do it from this point. So we'll go down 1 and right 3. 1, 2, 3. So what if you chose to put the negative with the 3? It will also work. So let's say I put the negative with 3. So this means we're going to go up 1 because the 1 is positive and back 3 because the 3 is negative. So let's see what I would get. If I started at this point, I would go up 1 and back 3. 1, 2, 3. If I started at this point, I'd actually end up going off my graph paper. Up 1 and back 3. 1, 2, 3. Okay, so notice there are many different ways to use your slope. And all you need to do is give me one extra point. Notice how many points did I find? 1, 2, 3, 4, 5, 6. I found 6 points. That's 2 times what I need you to find. So please just find one extra point. All right, so let's go ahead and draw in this line. Oh, they pretty much match up. Okay, I'll go ahead and draw in that line. Here we go. So if one of your points is not on the line, let's say I graphed a point and it was out here, you'd know there was something wrong with your calculations because they should be lining up. Notice all these points lined up. So if a point is not lining up, there might be something you need to fix in your work. Okay. Whew. What's the last step? Identify where they intersect. Okay, so where do these two lines intersect? Well, right here. And what is that point called? Remember, if they intersect at one point, our answer needs to be a coordinate point. So what's my answer? Well, this point is 1, 2, 3, negative 3, and then down 1, 2. Negative 3, 2.